So we just spent 2 videos on how to do limits, on the nuts and bolts of the mechanics of how we do this. And I just don't feel comfortable as a teacher if I don't talk about why that works. And so in this video, and I don't want it to be long, I want to talk about, like, when I ask you to do the limit as x approaches 2 of x squared minus 4 over x minus 2, why, and this is the important part, why is this equal to just doing the limit as x approaches 2 of x plus 2? And in case you didn't see that, it's one of those, like, we could factor this into x plus 2, x minus 2, the x minus 2's would cancel, and then we would end up with this over here. So the question is why? And I think in order to answer that question, the best way that I can answer that question is for us to think about this graphically, right? On the right side, you all know what the function x plus 2 looks like. You better know what it looks like, right? Think about what a y equals x plus 2 looks like, right? It looks like a line that's been shifted up by 2, and there it is. Now, again, think, and I know this is the end of your lesson sequence, but think, what does this mean? What this graph means is it means every single point on this line represents when you plug in this, you get back this. When you plug in this, you get back this value. When you plug in this, you get back this value. This represents all of the different values that you can get by plugging things into this. Now, this is the key part. What are you allowed to plug into x plus 2? You are allowed to plug in anything to x plus 2. Anything, anything, anything. And that's why this is a complete line. So now let's jump over and look at this one. What does this graph look like? You may be looking at it going, look, I have no idea what that looks like. I have no clue what x squared minus 4 over x minus 2 looks like. And yet you kind of do. You guys know that you can factor that and get x plus 2 times x minus 2 over x minus 2. These cancel, which means effectively this function looks almost exactly like x plus 2. This graph looks like this, with one exception. Am I allowed to plug in anything to this function? Can I plug in any number I want? And the answer is almost. I can plug in any number that does not allow this to be 0. I can plug in anything except 2. So this function that I just drew here is basically correct, with the exception that there is a hole in the graph at 2. Right? So every other point exists. In all regards, this function here, x squared minus 4 over x minus 2, is the same as x minus 2. The difference is that there is one singular hole right here where x equals 2. The question is, does that change the limit? Right? And I want you to think back to what we talked about like yesterday with graphical limits. In this case, as x approaches 2, hey look, my function is getting closer to 4 here. Yay, good job. For the blue function, as I get closer to 2 on the x-axis, my y values are also getting closer to 4. At that singular value, sure, it's missing. Sure, there's a hole there. But that doesn't bother the limit. That's why these limits work. When you cancel out a term, when you cancel out this x plus 2 here, it just means, hey, there was one little hole in the graph. No big deal. It's not going to change the limit. That's why we're allowed to factor and to cancel something out and then figure out the limit from the simplified function. I don't know that that's really going to be tested, but I need you to know that that's why these limits work. That's what's happening with these functions. So I hope that made sense, and I hope that getting to see a little bit more behind the scenes of what makes this stuff tick will help you to appreciate math more. For me, math is art. Math is beautiful. And it's because you can see so many of these things happening behind them. It's not just a mindless set of rules. It's something that makes sense and that's cohesive and coherent all the way through. If you have questions about these, write them down. Ask me about them during class. This is the stuff that I love to talk about. So I look forward to seeing you in class, and I hope the assignment goes well for you.